Okay, guys, let's see. The question says a logic expression is given S equals A and B, A and B and C, or B XOR C. Well, questions like this, they are pretty simple and pretty straightforward. Of course, the first thing you'll need to know is the gates. You need to know what's an AND gate, what's an OR gate, what's an XOR gate. Very quickly, I'm going to draw it on the side. So, this is an AND gate. I'm not one of the best at drawings, but hopefully it'll do good enough. So this is an AND gate, this is an OR gate, and this is an XOR gate. Okay, so yeah. Now what we need to do is let's go on and solve this one by one basically, and let's solve it by using your by solving the bracket first. So let's go on with this bracket. What does it say? It says A and B. So I know with A, I'm going to have an and. Yeah, with A, I'm going to have an and. So A and B. So A and B. Okay. And this has to be and with the C. So I need to have another and gate. Let me just put it over here. And this is going to be and with a C. I'm just going to put this with C. Now see very quickly guys, the reason is that of course our gates that we've learned, they can have only two inputs right now. So that's why I need to have separate gates. It's like I cannot do A and B and C in one gate because there can be two inputs. So I'm doing A and B and C. Now it says it has to be OR. We'll get to this later on because always remember the first step, the best way to do it is that, in the first step, what we try to do is that we try to XOR, sorry, we try to solve the ones in the bracket first. So it says B XOR C. So I need to have, of course, I'll need to take, a point from the line from B. This is my XOR gate, and this all is going to be, and this is going to be XORed with C. Okay, so this is essentially going to be XORed with C. So I've got B XOR C. Now this is done, and it tells that both of them, they'll be ORed with the both of them, like basically whatever I draw, this and this is going to be ORed, and that will be my final output for S. So there is going to be an OR gate. Here is my OR gate that basically goes into S, and the outputs, both of them, they'll be attached to this, and that's my final logic circuit. And I think it is pretty straightforward. This was my XOR and this is my OR. So hopefully um, this is clear. Now pretty sure the next question is going to be about the truth table. Well, yeah, it is actually about the truth table. Now, see, guys, solving truth table in such condition, it's actually pretty straightforward, to be honest. But the only little trick that you've got to keep in your mind, and that is why they also give you this working space, is that what we'll do is that at every every output from a gate, assign a point, basically, which means that what we'll do is when I say assign a point, I mean that what we'll do is we'll actually create a column, and that is what I'll do using my working space. So let's have a look at the first gate. I mean, I'm starting off, I'm just going to number these gates just for the sake of our understanding. So this is one, let me call it one, let me call it two, let me call it three, and finally this is four. So the first one, I'm just going to call it, maybe the output for this, I'm going to call it O1. The second, I'm going to call it O2. The third, I'm going to call it O3. You can name it anything. The reason I'm calling it O1, O2, O3 is because output 1, output 2, output 3, so on. And the final one is S. So I don't need to have an output for this one. So I'm going to do what again is with my O1, O2, and O3. I'm just going to quickly create my columns over here. So this is my O1 column. Um, this is my O2 column, and of course finally this is my O3 column. So now what we'll do is that it's going to make the process so simple. What I'll do is I'm just going to fill in my O1, O2, and O3 respectively with the inputs and the outputs that they're getting, and with the help of that I'm just going to eventually get my output, which is S. So let's see. Yeah. So let's see. So O1 is in a simple AND gate. The output O1 is with A and B, and it's a simple AND gate. So what I'll need to do is I'll need to process these inputs, with an AND gate. So 0, 0 is 0, 0, 0 is 0, 0, 0, another 0. Remember, what I'm considering is I'm considering only A and B for O1 because A and B were ANDed, and the output for A and B is actually O1 after I AND them. So 1, 0 is 0, so finally 1 and 1. So that's my first column done. My second column is for O2. Remember, my O2 is what? My O2 is for B. Sorry, my O2 is for C. C, there you go, this thing C, and the output which is coming from the first AND gate, which is O1. So basically for my O2 output 2, I will need to consider what? I need to consider C and I need to consider O1. So basically these two, C and O1. So 0, 0 ANDed is 0, 0, 0, 0, 0, 0, 0, and a 1. Okay, simple as that. Let's go and have a look at O3. Now O3 is an XOR between B and C. So for my O3, what will I need to do? For my O3, what I'll need to do is I'll need to consider B and C. Yeah, so just a sec. Yeah, so I'll need to consider B and C. So let's see, 0, 0 is a 0. Remember, XOR is 1 if both the inputs are different. Like 0, 1 gives me a 1, or 1, 0 gives me 1. The remaining ones are going to be 0. 0, 1 is a 1, another 1, 0, 0, 1, 1, and finally I'll have a 0. Okay, now my last column is left, which is S, and remember, S is basically an OR between O3 and O2. So for S, I'll need to OR O3 and O2, which is these two columns. So let's OR them. So I get a 0, 1, 1, 0, 0, 1, 1, and a 1. So that is finally what is going to be my answer.